Today we are going to look at another interesting topic in mathematics known as modular arithmetic. Alright, now modular arithmetic is a special type of arithmetic involving only integers or whole numbers, in which numbers swap around after reaching a certain value known as a modulus. For instance, if you're asked to compute the set of residues for numbers in mod 4, now the set of residues for numbers in mod 4 includes we're going to start with 0, then we have 1, we have 2, and we're going to end it at 3. We're going to explain why the set of residues for mod 4 ends with the number 3. Okay, now if we pick the first number, which is 0, for instance, now 0 in mod 4 is equal to, now because this 0 is less than 4, we're going to put down the number 0. Now, we pick the number 1. 1 mod 4 is equal to 1 because 1 is less than 4. Now, 2 in mod 4 will give us 2 because 2 is less than 4. Now, 3 in mod 4 will give us 3 because 3 is less than 4. But the moment we go beyond 3 and enter another whole number after 3, we're going to see that the numbers will swap around. Let us see this. Now let us see 4 mod 4. Now 4 mod 4 is equal to, now because this number 4 is equal to the modulus you are working with, so what we are going to do is to divide this number by the modulus and then put down the remainder. Remember that our interest in modular arithmetic is always on the remainder. Okay, now 4 divided by 4 will give us 1 remainder 0. We will now put down the remainder 0. We are going to see that we are now starting afresh. Now, the next number, the next whole number after 4 is 5. So we have 5 mod 4. Because this 5 is greater than 4, we're going to divide 5 by 4 and put down the remainder. And the 5 divided by 4 will give us 1 remainder 1. So you put down the remainder 1. Now, the next whole number after 5 is 6. So you have 6 mod 4 is going to give us, now we now divide 6 by 4. So 6 divided by 4 will give us 1 remainder 2. So we put down the remainder 2. Alright. Now the next whole number after 6 is 7. 7 mod 4 is equal to, because 7 is greater than 4, you divide 7 by 4. Now 7 divided by 4 will give us 1 remainder 3. So we put down the remainder 3. Now we are going to observe that if we go beyond this 7 and enter another number, another whole number after 7, which is 8, the numbers will swap around again. For instance, 8 mod 4 will give us, now 8 divided by 4 will give us 2 remainder 0. So we put down the remainder 0. Now 9 mod 4 will give us 2 remainder 1. So we put down the remainder 1. Now 10 mod 4 will give us 2 remainder 2. So we put down the remainder 2. And then 11 mod 4 will give us 2 remainder 3. So we are going to see that the moment the numbers reach a particular value, and that value is the modulus, which is 4, all the numbers there will now swap around. So that is how numbers are manipulated in modular arithmetic. So what you're going to understand here is that the moment the numbers are less than the modulus you are working with, put down the number. But the moment the numbers is equal to the modulus you are working with or greater than the modulus you are working with, what you're going to do is to divide that number by the modulus and always put down the remainder. Remember that our interest is on the remainder. That's why we say that modular arithmetic is also known as clock arithmetic. Thank you very much for your audience. Please don't forget to share our videos and then subscribe to our YouTube channel. God bless you.